Hi, I'm Val Huber of Automated Business Logic, and thanks for joining this demonstration of Openxava and ABL. We begin with the familiar cocktail napkins requirement spec. We have a database of customers' orders, items, and parts, and we need to make sure that the credit limit is not exceeded by the balance. We developers know our technology. A few weeks to prepare the pages and controllers, another couple of weeks to build the service layer to deal with all the multi-table dependencies across all the use cases such as insert, delete, make ready, reassign. But business users see things a bit differently. They see this as just a bit more complicated than a spreadsheet, so expect business results in hours. At Openxava and ABL, we ask, why can't it be as simple and fast to build an application as it is to imagine it? So rather than focus on improving code, we target its elimination through model-based automation. So instead of building a complex series of pages and controllers, you simply add annotations to a standard JPA model. The Openxava runtime uses this to build a complete user interface, no code generation, using Hibernate for database access. Let's see how. We've created an Openxava project in Eclipse using an AND script. The familiar project structure is visible here on the left. All we need to do to build our project is to define some JPA domain objects shown on the right. We've used Groovy, eliminating the tedious accessors. So here we see the customer domain object and the purchase order domain object with annotations defining their attributes, relationships, and database mappings. And that's all we do to get this application. You can see we've got a multi-column list, including capabilities to sort and filter data. The list is paginated, so a large query won't destroy system performance. Here we see the detail area, including foldable lists for the related purchase orders and audits. We can click on a purchase order to drill down and see its data, including its line items. And you can continue on down to edit a line item. So, it's a pretty remarkable application. All this functionality is built from our default model, which compares very favorably to other scaffolding. But of course, this is not a polished application. On the UI side, we want better layout. We should group the fields, use tab sheets. And on our line item list, we want to show product names, not numbers, and enable us to choose a product from a combo box. And we need business logic. We need to compute the purchase order and customer totals and ensure they don't exceed the credit limit. The modern way to define models is by annotations, just as we did for JPA. Openxava provides a rich set of annotations for presentation, such as the one shown here that groups customer attributes and defines tab sheets for purchase orders and audits. Just by defining 4 such annotations, along with the style sheet, results in the following very polished user interface. Here we see the grouped customer attributes and the tab sheets for purchase orders and audits. Drilling into the purchase order, we see that the line item list now contains the product name, and if we drill into the line item, we see we have a combo box to choose the product. All this from our annotated domain model. No HTML, no controllers, no code. But what about the business logic? ABL uses the exact same annotation-based approach for business logic. As you can see on the left, we declare a logic class for each domain. The logic classes are shown on the right. Let's look a little bit closer. Here we see the customer constraint that the balance can't exceed the credit limit. The balance is derived as the sum of the related purchase orders amount total for unpaid ready orders. The amount total is itself derived as the sum of the line item amounts, which is the quantity times the product's price. And that's it. Our annotations correspond exactly to our cocktail napkin. Executable requirements. No code, in fact, much more like the spreadsheet our business user had in mind. Let's see how our customized UI and our logic work in execution. The obvious case is creating a new order, but there are several other use cases that need to be taken care of also. For example, if we pay an order, the system will recognize the dependency from the customer's balance, so it adjusts the balance. If we delete an order, the same dependency again adjusts the balance. These dependencies chain over multiple tables in a simple and natural way. If we choose a different product, the system computes the line item amount, which adjusts the order total, which in turn adjusts the customer's balance. And finally, if we try to alter the quantity improperly, we see that our derivation results are governed by our constraints, resulting in the error message shown, which can be easily customized. So how does this all work? Actually, pretty simply. As a developer, you simply define your annotated domain objects and logic classes. That's all we've done here. There is, again, no code. The Openxava controller issues updates through Hibernate. The transaction logic engine plugs into the Hibernate event model. It finds your business logic, analyzes its dependencies, and executes it in a correct and efficient order. Note that this logic is enforced regardless of the client. So, in addition to Openxava applications, you might also have automated logic for web service transactions. We characterize business logic as declarative, often described as what versus procedural how. To be a bit more specific, declarative has several important implications. Reuse is automatic. So as we saw in the demo, logic imagined for place order is automatically reused for delete order, pay order, reassign product, and so forth. Optimizations are also automatic. For example, the customer balance is computed by one-row adjustment updates, avoiding the geometric reads of all the orders and their related line items. And logic is automatically pruned to eliminate database overhead. For example, changing the order notes does not activate adjustment logic. Finally, ordering is automated, based on the automatic dependency analysis. So for maintenance, you simply change the logic. No more archaeology to decipher the ordering of a previous implementation. And oh, by the way, if this thing ever catches on, so Openxava and ABL can make your organization much more agile in responding to business change. This entire app took 9 annotations. By contrast, the business logic alone required 500 lines of code using a traditional approach for dependency management over multiple use cases. This approach is very easy to adopt. Automation eliminates the complexity of the Java stack, so you're productive immediately with a very small learning curve to master the declarative approach. Both products are open source. Importantly, the declarative services can be extended using standard Java. And the result is enterprise class applications with the expected levels of polished user interface, adherence to standards, automated integrity, and scalable performance. Well, that pretty much wraps it up, but of course seeing is believing. You can follow the links to perform this complete tutorial in 20 minutes from scratch. So thanks again for your time, and we'd love to hear from you.